Hey guys, Pankaj here. Welcome back. So in today's video, I'm going to start very basic machine learning algorithm. That is nothing but simple linear regression. Okay, so we'll see what it is and what is the mathematical intuition behind that algorithm, as well as a couple of examples. Okay, so let me share my desktop. Okay. So we'll see what is machine learning, linear regression in machine learning algorithm, what types of linear regression, mathematical intuition behind linear regression. So I'm going to show with the help of graph also, and what are important libraries to load to perform the machine learning algorithm or to develop the model. Okay. And we will take salary dataset as a very basic, or this is also known as a toy dataset to perform simple linear regression. Okay. We'll see line plot of experience versus salary, scatter plot, then converting single dimension to two-dimensional data, which basically machine learning algorithm will understand. Okay. How to create train and test data. So we'll understand what is train and test data and how to create them with the given data, and how to create the linear regression object from the given function. Okay, then we will do best line fit creation with the help of linear regression model. Okay, so then once best fit line is created, then we'll see how to predict the salary based on the given number of experience. Okay. So these things we are going to understand with the help of graph, like what is best fitting, what is text tree data, what is train data, and why we have to split, and how much test data you should consider. Okay, then once data is like we have predicted data, then we'll do the plotting so that you can understand what is your actual data and what is the predicted data, what is the difference between this and how it exactly looks like. Okay, we'll be doing a regression plot also with the help of Seaborn library. Okay, and we'll do KD plot also just to compare what is their PDF or probability density function between the predicted one and the actual one. Okay, and how to evaluate the linear regression models, because this evaluation is also very important, which is going to tell like what is the performance of your model, whether it is performing well or it is not at all performing. Okay, and at the end I have written some of the very commonly asked questions in the linear regression. Okay, so we'll see what is residual, what is the cost function, what is bias and variance. I'm going to explain about this with the help of graph. Okay, and what is the underfitting model, what is overfitting model, and how to overcome from these kind of models. Okay, so with the help of region lasso regression. So this I'm not going to cover today, but in the next video I'm going to make what are the various ways to overcome from underfitting and overfitting. Okay, so let's get started. So before that, let me read what is linear regression. Okay, so in simple term, linear regression is a method of finding the best straight line fitting to the given data. Okay, so when you say best fit line, right, you would have also read in I think 10th or 11th standard, or maybe in the graduation, right? So we have the line equation, right? Y equal to mx plus c. So if you have given data x and y, and if you draw a line, so what is the best fit? So how do you call best fit basically? Okay, the best fit is nothing but whatever data you are going to draw in the straight line, how far it is from the other data. Okay, so best fit will be like difference between the actual and the predicted data, and their difference should be very minimum. If you get the minimum error based on various different line plotted, then whichever is giving the best what do you say minimum error, that will be called as a best line. So I'm going to show with the help of graph, then you will understand what I'm talking now. Okay, in technical terms, linear regression is a machine learning algorithm that finds the best linear fit relationship on any given data. Okay, between independent and dependent variable. So you have given a free, let's say if you remember in the EDA, right, exploratory data analysis, we took the very basic data set called Titanic data set. Okay, so we had so many columns, right? So those columns are nothing but feature, let's say name, age, gender, then the P class, survived or not survived. Okay, and what to say, in which city they boarded. So all those are nothing but the features. Okay, and those are nothing but independent feature, and dependent feature is nothing but the one which is nothing but a target value. Okay, so our target value in the Titanic dataset was whether the person who boarded in the Titanic whether survived or not, whether they died or they were alive. So we had 0 and 1, right? 0 means dead and 1 means alive. Okay, so similarly we'll be talking about this also. So there, that's what they're telling, between independent and dependent variable. So in this case, if you plotted data, so x is your independent variable and y is your dependent variable. Okay, so x is nothing but a feature and y is nothing but a target. Okay, it is mostly done by sum of square residual method. So we'll see in the graph. what is the types of regression? So we have simple linear regression. So what is simple linear regression? It's basically a single independent variable is used to predict the value of a numerical dependent variable. Okay, so let's say instead of name as gender, you just have, let's say, what do you say? And we had P class also, right? So let's say you have only P class and survived or not survived. The person who boarded in the first class, second class, or third class compartment, whether they died or survived. It's only one independent variable we have given. Okay, so that is what is your simple regression model. Okay, so when you consider your name also, age also, and maybe their salary, let's say, so if you consider multiple features, I mean that is nothing but your multiple linear regression. Okay, if more than one independent variable is used to predict the value of a numerical independent variable, then such a linear algorithm is called multiple linear regression. So today I'm going to talk only about simple linear regression, how the model, how to create the model, how to arrange the data, and maybe I'll make another video for multiple linear regression also. So what is mathematical intuition? So before reading this, let me just go to I'll go to whiteboard. Okay, then I'll explain what is the line equation. So let's say I have line here. Okay. Okay, and you have data here, let's say some data are there, and maybe it has some linear relationship. Okay, so we have already seen about this under variance, covariance, linear relationship, right? How the data is correlated. Okay, so let's say when x is increasing, and sorry, x is increasing, y is also increasing, right? So it has basically positive correlation. Okay, so here we are not going to talk about this, but I'm just plotted one data. So here is nothing but your x, and here is your y. So x is known as independent variable. Let me write this independent variable, or this is also known as feature. Okay, and y is nothing but your dependent variable. Dependent variable, or this is also known as basically target. Okay, and if you plot a basic line here, right? So basically that is called a regression line. Okay, so if I plot a regression line here, this will look like this, correct? So in this, what is happening? So basically this is nothing but your line equation, right? Let me write line equation, which is nothing but y equal to mx plus c. So y is nothing but your dependent variable. Okay, m is nothing but your slope, and c is nothing but your intercept. So how they look like in the graph? Okay, so let's say your another line, you have another regression line, which is nothing but passing like this. Okay, so this part, when x equal to 0, this is called your intercept. That is what is your c, intercept. Okay, and whatever you see, right, this is nothing but your slope, and this is nothing but your slope. Okay, I'll just mention slope is nothing but your m. So there's a formula to calculate, right? This is y equal to mx plus c. You just remember this is a line equation, and this is what is being used in the linear regression model. We are going to plot a best fit line, and once it is plotted, then we can calculate the residual. So what is residual? Basically, whatever data you have, right? How far it is from your predicted line or the best fit line. Okay, so how it is basically calculated? Let me just show you guys. So let's say you have another, let me just draw another line here. Okay, and here is your data. So data is something like this. Assume that this was a regression line and we have the data. Okay, so now to calculate the residual, right? So what, as per algorithm, what they say, basically you have to find a distance between this to your predicted data. Okay, this is my predicted data, and here is your actual data. Okay, so what is the distance between these lines? Okay, if you plot like this, then whatever differences are there between these data, that is nothing but your residual. Okay, so I'll just plot here what is your difference between actual and predicted data. This might be asked in an interview also. Right? What do you understand by residual? That is nothing but the difference between actual and predicted data is residual, or it is also known as, or it is also known as error. Okay, so what is error? Basically, you have, let's say, this is what you are predicting, right? Y equal to mx plus c. Okay, so this is what you are predicting. So let's say you have actual data here, which is nothing but represented as y, and the predicted value is nothing but this one. That is y dash or y. Some people use y hat also. Correct. So what is the difference between y and y hat? Okay, or y minus y dash. Okay, what is the difference between this? Let's say this was y1 and y1. This is, let's say, y3, and this is your predicted y3 dash. Okay, so what is the difference between y3 minus y3 hat? Okay, so whenever you calculate this distance, that is nothing but known as um, error or residual. Okay, so that's what linear regression is going to calculate. And wherever you get all the error, once you get all the error calculated for all these variables, right? Let me choose another color. So you calculated error for this, and this line, whatever data you have, data point. Or once it is all calculated, then you calculate sum of 1 by n I minus y hat. This is, let's say, I equal to 1 to n. Okay, so whenever you see this has to be very minimum, I would say, and that is nothing but your error, right? So when you calculate all error, then make sure that your error is very minimum. So this we are just taking like mean difference, correct? If you take the square, this is also known as mean square error. Okay, so these are nothing but some of the techniques which will tell you how much error you are getting and how best is your model. So lower the error means best is the model, best model. If you're getting some value, then definitely, I mean, higher the value means your model is not the best. Okay, so these are also known as the cost function. So basically, you are having actual and minus your predicted. So this has to be minimum. Basically, we have to minimize these. So there are various techniques to minimize. We'll see in the next video. But just for timing, remember how the best line is calculated. The best fit line will always calculate your difference between the actual as well as predicted value, and sum of all the difference between actual and predicted will be divided by total number of values and their square difference. Okay, so that's how you get the best fit line. So let's say you have another line here. I'm just going to draw it here with the help of red. So let's say you have another line which is somewhere, going like this, correct? So you calculate the line, I mean error based on this line for respective points like this, and here also, and here also, and here also. You calculate the error. Okay, and whichever, let's say this is giving error, let's say 3.0, and just for example, okay, and for this line I got error as 2.0. So where is the minimum error? This with this line, right? So this is called your best line. That's how the best line will be calculated with the help of linear regression model. Okay, so that's the mathematical intuition behind this, all based because of this particular line equation. Okay, so that is what I have mentioned here. So as we know, y equal to mx plus c, and y is dependent variable, m is your slope of a line, x is independent variable, and c is your intercept. Okay, so how basically it is calculated when multiple features are there? Exactly y equal to mx plus c, but you will have some weight assigned, let's say w0, and w1 is nothing but your, again, slope of one feature, and w2 will be slope of another feature, like that, and w0 is nothing but your intercept. Okay, so what are the important libraries to load to perform linear model? Okay, so let me just import all the libraries. So first I'll import, let's say, import numpy as np, import pandas as pd, then we have import matplotlib dot pyplot as plt. These are very common library, and you must, before doing any work, you just import it, because not now, at least later you are going to use it. Okay, and then we have import Seaborn as SNS. Okay, these are common library. Now let's load machine learning related libraries. Okay, so as I mentioned, scikit is the one which I am going to use, and like everyone is using very heavily, right, for machine learning as far as Python is concerned. So we are going to use same library. Okay, the first one is the linear model. So we have sklearn. So all those libraries are already loaded in the Anaconda. Okay, so as I mentioned, Anaconda, if you have loaded these library, you don't have to explicitly load it. It is there by default. So from sklearn dot, we have something called linear model. Okay, from this model you have to import linear regression. Okay, then from sklearn, let's say we have data sets. Okay, import, I'm just showing one example, though I'm going to load external data, but you have some predefined data also, which will be very good if you are going to quickly will quickly want to load the data without external interference. Machine learning library that is nothing but sklearn is already having plenty of data, so you can load that. Okay, so we have something called load. If you see here, load SVM light, wine data, linear Boston, diabetes, iris, file, sample images, SVM light, breast cancer, sample image, all data are there. So I can diabetes is nothing but Boston diabetes. Mostly it is related to what do you say, we have two kind of regression, right? Simple and multiple linear regression. So if you want to perform multiple linear regression, go with diabetes or Boston dataset. Okay, so for simple one, it was not there. That's why I had loaded on external data. So just for time being, I'm just going to load for you guys. So load, let's say Boston. I'll show you also. Okay, then we have, once you generate the model and you do prediction, and also before that you need to divide the data also, right? So let me talk one more thing here. So let's say you have a feature here. So let's say data, you have let's say x1 x2, right? So here you have some data, let's say 10.3, 14.4, 16.0, 18.9, and here x2 is nothing but, let's say some data is, let's say 0011. Okay, so this x2 feature is nothing but your target feature. Just one example, okay, because here it has only two values, right? And here this is nothing but your continuous data. Okay, so this is known as continuous data because n number of possible values are there, right, between two numbers. Continuous data, and this is what we are going to put. Let's say we have 20.0. So based on this best fit line, whatever our linear model is going to give, it is going to predict this target, whether it is 0 or 1. That is what we are going to find out. Okay, so this is nothing but your feature one, this is nothing but your target. Okay, so as I mentioned, we are going to talk about simple linear regression where only one feature is there, f1, and one target is there. So that's what our data will be. So we are going to have salary data set. Okay, so what salary data set is doing basically, or what it contains basically, it has number of years of experience and their salary. Okay, so let's say either 10, we have 10 years, then salary will be, let's say $10,000. Okay, here let's say we have 9 years, then here $9,500, correct, $9.5, or we $9,500 animation. Okay, here we have 20 years. Okay, then let's say $15,000. So like that, it has all the number of years and their corresponding salary. So let's say I get 5 years. So based on 5 years, what should be the expected salary? This is what we are going to predict. Okay, so this is only one feature and one target. So salary will be our target here, and number of years of experience will be your Y. Okay, oh sorry, this is your X. Sorry, this is your Y and this is your X. So this is your independent and this is your dependent feature. That's what we are going to see here. Okay, and whenever you have the data, so what we do normally, let's say you have data where your x is nothing but something and y is nothing but target. Okay, so here you have x1 till x 1000. Okay, so similarly y1 till y 1000. So to perform the linear regression model, right? So what we have to do basically, we need to do the training and testing data set. Okay, so out of 1000, we will take first 900 data for your training. Okay, and next, let's say training 900 we took, and 100 data will use for test. Okay, similarly from here to here, y train will take. Okay, and y test will take. So y test we know already because it is labeled data, right? But we are going to predict this data. So that will be called predicted data once you predict through the algorithm. Okay, so then you find a difference, as I mentioned, right? Y minus y hat to find the error. If it is minimum, then your best fit line will be generated. If it is maximum, then we cannot do that, correct? I mean, your basically model is not the best fit. Okay, so we are going to do given data set in the train and test splitting with the help of another function called from scale learn dot, that is called model selection import train test split. Okay, so this is going to give idea of flexibility to divide like how many data set you want for training and how many data set you want for testing. And you can always divide, let's say 50-50 or 70-30 or 80-20, all the ratio you can do. Once it is done, then we are going to provide best fit, and after it is done, we'll do the prediction. And once prediction is done, you are going to do model evaluation whether it is perfect or not. Okay, so we have something called for model linear model evaluation from scalar dot model, is that model selection import. Let's say we have something called, what was the value, just check, model evaluation, what other values we had. So I think, yeah, that comes under metrics basically. Okay, so here from sklearn we have various metrics. Okay, so for regression model we have different metrics, for classification model we have different metrics. Okay, so we are going to use R2 score. Okay, then we have something called mean error squared, which I already showed with the help of formula. So absolute error is there, and we have something called squared mean. Let me just check mean squared error. Okay, so basically how it is calculated, let me just show one formula. So either you do 1 upon n and I equal to 1 to n, y minus y hat, take the square. Okay, I 9. So that is called mean squared error, taking the square. Okay, then we have 1 upon n, summation of I equal to 1 to n. Then we have y hat square, sorry, not a square, basically it is just absolute value. Okay, so this is nothing but mean absolute error. So you have values formula, whichever you want you can do that. We have another formula called I equal to n, sorry, 1 to n. Then we have y I minus y I hat and square, and this is nothing but root mean squared error. Whichever you want you can use it. Okay, then we have one more thing called R2 square, right? R2 square or R square also it is known as. We have 1 minus R, we have 1 minus y hat square, y minus y hat square. Okay, so this is for R2 square. So whichever you want. So this is what we want to use basically, because R2 square best will be your 1.0 value. This is the best value. if you are getting R2 square as best value 1.0, that is called best, what to say, you have the best fit model. Okay, it will be 0 means very bad and 1.0 means best. So you will be getting the value between 0 and 1.0. Okay, so let's talk about this. We have already imported those libraries now. And what else? I think this should be fine. Now let's go ahead and import it. So mean square error, what is that? Yeah, there was some typo. Now let's load the salary data set. So what we have, df equal to pd dot pd dot read csv. We have salary data. Okay. Now let's load it, and I'll just show df dot head 5. So what we have, years of experience, then 1.1 year experience, then we are getting 39,343. I don't know, it's a rupees or dollar, but whatever. We have some unit. Okay. Let's say 2.2 years, then $39,891 or rupees, whatever. Okay, so this is one feature. So years of experience is nothing but your F1, that is feature 1, and salary is nothing but your target. Okay, so once you have this, what you have to do, another thing to note, that in the machine learning, or in the terminology when you talk like machine learning or AI or deep learning, we always represent X as nothing but your feature, which is capital S. There is no hard and fast rule, but this is the standard one, and small y is nothing but your target. Okay, so always go with this notation, so it will be helpful for you guys to understand any external code way when you are referring it. Okay, so I'm going to make X equal to df dot salary. So X is your independent, right? So I'll just make years of experience, and Y is your target, right? So we are going to predict the salary. So we can make df dot salary. It's capital S. Okay, now if you just take X dot shape, it is showing what? It is just single dimension. Okay, so machine learning always needs 2-dimensional data. Remember that. So we have to change this. How to change it? Basically, whatever you have read, right, always read in the form of data frame. So what I can do, I can just put a bracket here and put this. That's all. So it is going to return me in the form of 2-dimensional array. Let me just show you guys. If you read like this and just read this again, see here. Yeah, we need to put 2 bracket. I forgot to put that. If you put this, automatically it will make 2-dimensional. So like number of observations, that is total rows, and number of column, that is always 1. Okay, so let's run this. Yeah, so total 30 observation and 1 column. Okay, and here total 30 observation, 1 column. Okay, so now you have got the data, and its total shape is what? So if you just take df dot shape, total 30 observation, and number of columns are 2. Y, years of experience, and salary. Okay, so one of them is target. So that's why we have splitted that. So Y should always be your target, capital X should always be your feature. Okay, so now let's plot some data. So line plot for experience versus salary. So I'll just use plt dot plot, and here I'll just put X, and here I'll just put Y. Okay, so let's take a look. This is how it looks, right? So our number of years of experience going high, your salary is also going high. Okay, now scatter plot for experience versus salary. So what I can do here, scatter. So whenever you are doing prediction, right, so scatter will be better, and later you plot the regression line on that. Okay, so now convert a single dimension to 2-dimension, which I already showed here. So this is the way to do that, because that's how your machine learning algorithm will understand. Okay, now creating train and test data from raw data. So this is another step which you must follow that. So how to create that? So we will use X train variable, then X test variable. Similarly, we need Y train dot Y test. Okay, so if I'm going to use that function, there is something called train spread dot split. So it needs arrays of all the values. Okay, so what array we have? We have X, that is nothing but experience, and Y. So the way you have written, right, in same order you should write. So X is for your independent variable, that is nothing but your years of experience, and Y is nothing but your salary, which is your target. Okay, and here one more parameter is there, which is very important, called test size. So this test size is nothing but how much percentage of data you want to extract from the raw data. Okay, so as I mentioned, let's say you have 100 observation. Out of 100, 20 observation, I want to hold it for testing. I'm not going to give that data for training. Otherwise, see, let's say out of 100, you train all the data for developing the best fit, right? So best fit line or machine learning algorithm has already seen all the data. It is always going to provide the very best accuracy. But what about the data which it has not seen? It may not work. Okay, so we'll talk about this, comes under overfitting and underfitting. So we'll talk about that. So always reserve some data or some proportion of data from the raw data for test size. So test size, this takes the percentage. I'll make sure that we are taking 20%. That is nothing but 0.2. Okay, and another parameter is nothing but your random state. So this is nothing but, let's say whatever I am using, I just put any number here, some random number. Let's say I'm putting 10. If you are going to run this notebook without this particular variable, right? So whatever result I got, you may not get the same result. But if you put 10 the way I have put, so my result and your result is going to be exactly matching. Okay, so that's what is this. Now it is created. So let's find out what xtrain contains. You see here, xtrain is nothing but years of experience. It is going to shuffle the data and pick top, let's say whatever we have given 20, right? So 80% of data will be randomly selected from the given data. Okay, I can just put shape here. Okay, and similarly you can take x train. Okay, so this is nothing but your, sorry, x train we have already taken. We will take x test. See here, this 20% of data. Okay, so out of 30, 20% is 6, right? So we have exactly 6 values, correct? And here if you take x test dot shape, see exactly 6 values in one column. Okay, so that's how you do. And if you just take y test, so this will be your 6.1 again, because their dimension should be exactly same. If you have one less, one high, it is going to create a problem. Okay, then what else we have? Y test data is a y test shape. Similarly, white and y shape also you can do that. Okay, now create an object from linear regression. Now we are ready with your data, and that data we are going to feed it to linear regression algorithm. And what it is going to do is what it is going to do. See, so it is going to plot all the data. Internally, it will start calculating the best fit line based on whichever line is giving the minimum error. Okay, so let's do that. I'll create the model here. So since it is going to create an object, I'll give object name as LR, that is nothing but linear regression model, and just use linear regression, give the function name. It has a couple of parameters. So by default, we'll go with the fit intercept true, because that's how it is going to fit the line, right? Normalize, by default it is false. Copy x true, so it is not going to modify original data, rather it will make a local copy. Do modification, do all the best fit and all, then create the copy of it. Number of jobs, we'll go with none, because we have, it is basically, let's say you have multi-core PC, right? So you can give the number of jobs to, basically same job can be executed in parallel if you have multi-core architecture. Okay, positive, this you leave it is not required. If you do that, then LR model will be created. Okay, and once it is created, you can do a lot of things here. See here, copy x, fit, get params. So what parameters are there? So by default, whatever we have selected, everything is going to be returned. Okay, now LR dot, let's say we have number of jobs we have not selected, it is going to be false. Normalize, it is going to return false because we have not given anything, correct? What else? It is basically getting what and all parameter you have set to just check it. Okay, and after that, what you can do, we are going to do fit. Okay, so fit is nothing but we are ready with the data and let's start training. Okay, so fit is nothing but getting the best fit line by training the data. So I can just do fitting here. See here, fitting data into linear regression object to have best fit line. So LR dot fit, that's all. You don't have to put anything. Okay, so all you have to do is whatever x train and y train you have to just do that, because I want to train our X-train data and corresponding their salary. Let's say years of experience I have given, their corresponding salary also we need to provide, right? So I'm just going to give Y-train. Okay, now it has fit. Now let's do the prediction. Okay, so predicting salary of a given number. This is very simple. You just fit the data, or after fitting, you just do the prediction. So basically, if you see actual line of code is nothing but 4 or 5 lines, nothing much. Dot predict. Okay, so for prediction, what it needs, X. This X is nothing but the test data which you have reserved for testing your model. Okay, so I'm going to put text, and since it is going to return the salary, I'll just mention Y pred, because that is the target, right? Y pred. So this is what this is the salary which has been predicted by the model. Okay, so let's see how accurate it is. So plotting predicted salary and actual value. How to plot that? So I can do plt dot plot. So what I can do, X train or X text. So for the test, what was my salary? Actual salary. So I can just give X test. This was my actual salary. And let's do the scatter plot. This will make more sense. So plotting predicted salary versus actual. So predicted salary is this. And here is your predicted salary. And let me give color as color equal to, let's say I'll give red, and since this was original, so I'll give color equal to green. Okay, and let's give alpha equal to 0.5, and this I'll highlight this with more alpha value. Maybe I'll give 0.8. Okay, so there is issue, path collection object has no color. There is some issue here. Yes. Okay, see here, the actual data, I can just put the label also, then it will make more sense. Label equal to true value, or maybe I'd mention actual value. And here your predicted value. After plt dot listen, plt dot show. Okay, so your actual value and if you see, right, I mean actual predicted value is also very much close to the actual value. So this also, this graph also tells like your data is, I mean your model is very perfectly working very perfectly, because it is very closely predicted the value. Okay, so we'll see how also how mathematically it is proving that. Okay, so this is what about plotting a predicted salary and actual value. Okay, now we can do the plotting of regression line as well. Okay, so plotting regression line or predicted salary and actual value. So SNS dot regression plot. So regression plot of Y, let's say we have Y test. What is that? Sorry. Regression plot Y underscore test. So Y must be the same size. Okay, so what and all I'm missing, let me just check. So maybe what I can do, I can take this. So plotting predicted salary and actual. Okay. First, I'll take this one. Make it more clear graph. Okay. Okay, so this is another way to show the data. So what we have been X train, Y train we have taken. Okay, and we have taken X test versus Y test and X test versus Y pred. Okay, so if you see the blue level, right? So blue is nothing but your blue dot. This is the actual value. Similar, very similar thing we have shown here also, right? But here I've taken the X train and Y train also. The plotted all the values. Okay, X test versus Y pred. So that is nothing but this is what we have seen, correct? Now let's talk about other one, regression line. So regression line, how you can plot basically. So I can just write like this. Okay, so we have direct regression line plot in SNS. So we can just go at X train, Y train, And after that you plot x test, y test, which we have already seen here, right? It's exactly same, but only thing is we are just plotting the regression. Let me just show here. Here what we are doing, we are just going to plot one regression line here. That's all, nothing else, with the help of SNS. Okay, this will be very straight line. Okay, so now we got this, and you clearly see that, right? It is very much visible also. Your green is nothing but your actual value, and the predicted value is exactly at the regression line. Okay, so once we have this, right, you can do some KD plot also, that is kernel density estimation. Okay, we have seen, right, this is nothing but your probability density, and we'll see like what was your actual and what was your predicted. Okay, so here we can do SNS dot KD plot. Here you can test y test. So what is the problem here? If using all scale, you must pass an index. Okay, so let me check what is the index missing here. Okay, so I think we have to make it in the form of list, okay, which is not done here. So since you are making y test, so let's see why it is telling like this. Okay, because it is data frame, right? So what I can do, I can take y test to list. To list. Let's see if that works. Wait. Y test dot salary I should take. Okay, let's see if that works. Okay, this is also fine. And now the next one, what we can do, y pred. And since it is going to be a normal array, it is not going to plot it. So what we have to do, y pred, we have to definitely convert into in a meaningful format. Okay, so let's see what it has. Y underscore pred, it is nothing but an array. So I can make it to list using this function. Okay, and after that we'll take 0. 0 is giving one value, so I think this should be good enough. Numeric date time is required. Okay, what is the issue? Let me just check. No, it is prediction 0. Y pred 0. This one. Zeros would have worked, but why it is not working? All those 0 column. Let me see why it is not working. Oh, we can create a data frame basically. Okay, so here y pred df equal to pd dot data frame. I can mention like this. Let's see if that works. Okay, then y pred df, I will take the 0th column, so it will just provide the whole data here. Okay, I think that should work. It's all basically, you know, we have to reformat data in the meaningful format. Okay, but this should be fine. So you see here KD plot of true. So I can just mention label equal to true, and this will be predicted. Predicted plt dot legend and plt dot show. Okay, you see here the true is nothing but your blue, and the predicted which one we don't see much difference, right? So this graph also tells like your model is going to work perfectly. We don't see too much deviation also, correct? If you have like really visually, if you can visualize the whole data, like we have too much variance or too much, what do you say, the graph is too much separated, then you can also tell like my accuracy is not going to be perfect about the model. Okay, so this was another graph which I want to show you guys to perfectly see whether your model is really working fine or not. Okay, but there are a couple of models, or there are a couple of metrics to see whether your linear regression model is perfectly working fine or not. Okay, so one of the best one is like R2 square for linear model. So we'll see how it works basically. So how you can confirm? So we have R2 score. So what it takes y true. So nothing but y test we had taken, right? And y spread. Between this is going to put everything in the formula, the one which you saw here, right? This one. Okay. And after it is going to calculate the score. So my score is 0.98, and which is very close to 1. And that's what I told, right? The best one, if you're getting best fit line, right, your value has to be exactly close to 1.0. Okay, so we already saw here. Our model is working perfectly fine. That's why we got 0.98. Okay, similarly, we have mean squared error, mean absolute error. So you can just put y test versus y spread. Okay, so this is absolute error. And here we have another thing called mean squared error. It is going to be very big value because it is doing the squaring, right? That's why we are getting this. But R2 score is the best one. If it is very close to 1, means your model is perfectly working fine. Okay, so that's all about this linear model, and we will see a lot of other details also, like what is underfitting, what is overfitting, how to overcome from this by using Regression and lasso regression, which we'll see in the next video. Okay, how to solve under and overfitting model, and what is the bias and variance. We are going to see this in the detail. Okay, what is the cost function? If you know the cost function, then only you can work on these Regression lasso regression. Okay, so I've just put this as a interview question because this kind of thing will be definitely asked. So once you prepare and once you start developing the model, I think you should go with these things, okay, before applying for interview. Okay guys, so I hope you liked this video and you understood how linear regression works. Okay, so in the next video we'll be talking a little more about linear and multilinear regression also. Okay, so that's all for today guys. Thank you so much. Those who have not subscribed my channel, please do subscribe and leave out the comment in the comment box if something is not clear. I'll help you guys in the next video. Okay, thank you so much. Bye bye.